All right, well, hello, geometry students. We're going to go ahead and jump into chapter 5. We are on 5.1. Hallelujah, the last chapter we'll cover, in this case, before Christmas. So here we go. It's called perpendicular and angle bisectors. So we've got a couple definitions, including their converses. And again, it might seem a little complicated at first, but I just encourage you to kind of get the big picture because uh, it's a little abstract as we get started. So let's first of all define kind of a starting word, and that is equidistant. What does it mean to be equidistant? Well, you can just see the two words here, equal and then distance. So the definition is pretty simple. When a point is the same distance between two or more objects. Okay, so I'll just use a really simple illustration here. If we have A, and then let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, and let's say that's point B. So then if I have 1, 2, 3, 4, 5 right there, and call this point C, same thing as like a midpoint. Point C is 1, 2, 3, 4, 5. 1, 2, 3, 4. Oh, we'll have to go ahead and make it even. Let's erase this real quick. All right. So 1, 2, 3, 4, 5, 6, 7, 8. All right. So make that point B. And then right in the middle, we have point C. And so you can see you've got 4 here and 4 units there. So that means point C is equidistant from A and B. Okay, so it just means it's the same distance between. When we say equidistance, equal distance. All right, so now that gets us to something called the perpendicular bisector theorem. I know that's something you've always wondered about, and now you're finally going to get it revealed to you, so you're excited. But here's what it is. It just says if a point is on a perpendicular bisector, then it's equidistant from the endpoints. So first of all, let's start with the if. So here's the if, and then we're going to have a conclusion with the then. So first of all, if a point is on a perpendicular bisector, what's that? Well, perpendicular bisector would be, we would have a point. Let's see, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay? And then if I put this right in the middle, so that point is bisecting the other, and then perpendicular, which means it cuts through it at a right angle. So that right there is a perpendicular bisector because you've got both 5 and 5. So it's bisecting it, this word, and it's perpendicular because it's at a right angle. Now, if you have that situation, then we have the conclusion. Actually, maybe we'll do it this way. We'll put our conclusion in blue. So then, because of that, any point on this line, like say here, is equal distance from the endpoint. So in other words, this distance must be congruent to that distance. So those are the endpoints here and here. And so those lines, the blue lines have to be equal. And if I can do that with any distance, if I just put the point here, that point is also equal distance from the endpoints. Not drawing very straight. Same idea here. If there's points up there, these points, if I measured them or calculated them, they are all equal distance. So if you have that perpendicular bisector, every point along there is equally distant from the points on the side. And we'll be putting up some examples of how you then make calculations from this. Then you have the converse. And so again, the converse is just going to switch the if and the then. So it's the same idea, but you can just realize it's the same as true. So if the red is, this time, if a point is equidistant from the endpoints. So say we have something like this. 1, 2, 3, 4, 5, 6. So I'll make it a little smaller. Okay, we got endpoints. And I know that, say you start with, I know I have this point, and I know that this distance is 6, and I know that this distance is 6. So that means, let's just call this point C. If point C is the same distance from A and B, then you know you can draw a line through C, and it lies on a perpendicular bisector. Then it must be able to draw a line straight through that point that creates a bisector, so equal sides on either side, A and B, and that it must form a right angle. Okay, so it's the same as the other one, but again, you can know it in either direction. Either you start with a perpendicular bisector and then know you have all those equal distances, kind of like wires going up to an antenna, or if you know you have equal wires, then you know it lies on a straight line that bisects the bottom and that angle it creates is 90 degrees. I know, I told you, stuff you've always wondered about. And second one, we have this other one. This is the angle bisector theorem, and that is if a point, so we'll start with that. If a point lies on an angle bisector, then it's equal distance from the side. So to illustrate this one, we need an angle. Okay, and then you have an angle bisector. So remember, bisector just means it cuts it in half. So that's just saying if this is a line that's cutting, let's call this angle A. If angle A is being cut evenly in half by this center line, we'll call the middle line M. If M's cutting angle A in half, then we know that it's any point on this line, let's go switch to blue, or then any point here, and again, my drawing isn't perfect, but because it's not, maybe it doesn't look like a real angle bisector, but then it's equal distance from there to there, okay? That the shortest distance is, of course, that right angle, but if I can go to the same point on either side, then I know that this is congruent to that. Or for example, if this was 8, this would also be 8 down here. And that's the same thing here. Let's say I put a point here. Well, imagine if the red arrow kept going, then that, say that maybe that's 10, but then that means this is also 10. It's always going to be equal distance, even if I did it down here. Okay, so it's the same idea as the perpendicular bisector, but this is for an angle bisector. All right, and then we have a converse, which is just going to reverse that. That is if a point is equidistant between two sides. So say you have an angle. I should go and just draw it the other way. Why not? Call this angle, whatever, angle J. J is a great letter. And say I have a point out here, and I know that this point is equal distance to either side. So it's either congruent, or let's just make up a number. It's 3 and 3. Just making those numbers up, but it's congruent. Then I know that if I take a line and I connect this point to this vertex, I know that what I did is I just bisected that angle. I just created two congruent angles. So in other words, like equal distance, equivalence to equal angles, or in equal angles, equivalence to equal distance. Okay, and that's the angle bisector theorem. Now you know, go tell all your friends. Alrighty, so questions, all right, questions. Now this first step, I can just basically, the hardest thing you're gonna do almost in this whole chapter, especially if you struggled with graphing lines, might be what we're gonna review right now. And so I encourage you, it's a great chance to review graphing lines, and also if you know graphing lines, you're in good shape. But here's the task. Number one says, what are 3 steps for writing the equation of a perpendicular bisector? So say I'm given these 2 points, -1, 6, and this other point, 3, 4. And it says you need to write an equation, not even just graph it, but you need to write an equation of a line that goes through it perpendicularly and bisects it equally in half. I kind of think of it as drawing the sword. We got the sword hilt, and then here comes the blade. How would we write the equation? I just drew that to visualize what it would look like. How can we actually write the equation to do that? All right, this is actually straight up from example 4 in the book. So if you want to follow along there or turn me off and just study that example, you can do that. But this is example 4. Here's the 3 steps. Step number 1, you want to find the midpoint. Okay, if something's going to be a bisector, then it must go through the middle. So I have this point. The problem in example 4 gives us this point, -1, 6, and 0.34. How do I find the middle? Well, we remember how to do that. You just need to add the x's and divide by 2. -1 plus 3 over 2. That's 2 over 2. So midpoint of x is 1. And then of the y is going to be 6 plus 4 divided by 2. That's 10 over 2. And so that is 5. So 1, 5 should be right in the middle of A and B. Let's check that out. Let's go over 1. Again, you can see my axis isn't drawn very well. Here's my x, here's my y. over 1, 1, 2, 3, 4, 5. Boom. I'm going to make it real big, but that's right. So you can see that's roughly right in the middle of A and B. So now I know the line, again, this, come back. This perpendicular bisector must go through this point 1, 5. So that's a key point on my line. All right. So now step number 2. Once you know the midpoint, then this comes the perpendicular part. So we figured out the bisector part. That is finding the middle. Perpendicular refers to an angle. So now I need to find, step 2, find the perpendicular slope. So in other words, if I can find the slope of A and B, I can know what a perpendicular slope would be. So let's figure out the slope of A and B. Since I've already drawn it, I'm just going to use my drawing to find the slope. I see that this line goes down 2, 1, 2, over 1, 2, 3, 4. Okay, down 2. So my rise is -2, and my run is 4. All right, let me erase this. I went ahead and did it since I had it graphed. And so then that simplifies to -1 over 2. So the slope of that AB line is -1, 2. It makes sense. It's declining, so it is in fact negative. So what's my perpendicular slope? I need to flip it over and get rid of the negative sign. So that means my positive slope is simply, right, make it positive. And so now my other slope is 2 over 1, or simply 2. All right, so that means that the line that goes through the middle of A and B and is perpendicular to it goes through point 1, 5 and must have a slope of 2. So in other words, I could even start to draw it. 1, 2, 1. 1, 2, 1. Or down 2, back 1. And that looks pretty good. That does in fact create a perpendicular line. So I can definitely draw it. There's my perpendicular bisector. What's the equation? So what's the third step we need to do? Well, we need to actually write an equation. So I'm going to continue with that right here. We'll scroll back up. But we need to use slope. Whoops. We need to use point slope form. And there's some shortcuts, but I'm just giving you the basic way to do this. Point slope form. So now I have a point of this line, 1, 5. I have the slope of this line, 2. And so now I'm going to use point slope form, which if you remember, and I'm sure you do, point slope form is y minus y1 equals m times x minus x1. All righty, so let's go ahead and plug in. I'm going to go off to the left here, sake of space. So my point is 1, 5. So that means I'm going to go y minus 5. I'll make those parentheses equals 2, because that's my slope, x minus 1, because my point was 1, 5, and my slope was 2. And now we just go ahead and solve this. Y minus 5 equals 2x minus 2. We're going to add 5 to both sides. So we get y equals 2x plus 3. All righty. So that is the equation of this line. And notice I can even see that that's right, because according to that equation, my slope is 2, but look at my b. My y-intercept is 3, okay, because that's mx plus b form. Now, if I go back up to my drawing, I can see where does my drawing here, where does it cross the y-axis? Right here at 1, 2, 3. So I can see that is, in fact, the right equation, okay? So a lot of work, but for now, it's just very good because it gets us more comfortable, and it's a review of finding midpoint. Step number 1, find the middle. Step number 2, find the perpendicular slope. Good review of slope. Step number 3, use your point and your slope to find your actual equation. So it's a good review of chapter 3. Encourage you not to wimp out on this because, again, you're going to need these skills over and over and over again. And I'm happy to help you. Okay, so that is finding the equation of a perpendicular bisector. Lots of work. Let's do the last couple questions. You'll see they're delightful compared to that work. So number 2 says, given we've got this triangle that I've already drawn, it gives you the measurement of PS, QT, and QS. And then it says, please find, I'm going to circle it, find PQ. So I want to find this distance here. I'm going to write in circle, just PQ. All right, well, we can see here that we have a perpendicular bisector. Well, how do I know that? Well, I can see that it's perpendicular, and I can see that it's equidistant from, because those are both 53.4. So even just your common sense without reasoning through it, you could probably guess that this distance here, PT, is probably equal to QT. Okay, that those two are in fact congruent. So that means they both equal 47.7. Alrighty, so if they're both equal to 47.7, then the entire PQ is just double that. Okay, it's just 47.7 plus 47.7, which comes out to 95.4. 95. Okay, so you'll see that kind of stuff is pretty easy. You begin to see things are just congruent. Number 4, same idea, but now it's going to use an equation. It sits there and tells us that PS, which is right here, is 4A, and it tells us that QS is 2A plus 26. Now we're going to ignore these measurements because those were for the previous problem. But so we know we have these two distances. We know it's a perpendicular bisector, so that means PS is equal to QS, which means our equation is fairly simple. 4A equals 2A plus 26. Okay, so we can just solve that bad boy. We're going to go ahead and add 2A or subtract 2A from both sides. Crosses out. So we get 2A equals 26 divided by 3. See, you guys glad those proofs are over? Just good old, oops, not 3. Good old algebra. And so now we can see that AA is equal to 13. If we go back and check the problem, they want us to find QS. QS. So we just need to plug 13 into the back into, oops, get my pen, plug QA back into here. And so we're going to go 2 times 13 plus 26. That's 26 plus 26, 52. Boom. Okay, so same, oh, you can't see that very well, but I'll scroll. Okay, 52. So fairly simple, basic algebra, and it's because you know the two sides are equal, so you set your appropriate equation, and then solve, and then don't forget to plug back in. The answer is not 13 because it doesn't ask for A, it asks for the distance of QS. And the last one is the same thing, but applied to an angle bisector, where they tell us that AD is, what they tell us AD is 61, CD is also 61, I forgot to write that. And so that means that BD here must be an angle bisector. It must have cut, this here must be congruent to this bottom one here. And so then it tells us that, number 6, ABC, so the entire angle ABC is equal to 48 degrees. Find CBD, CBD, so the smaller angle here. Well, it's an angle bisector, so that means that this bottom angle is half of the total angle. So that means angle CBD must be half of 48, 24 degrees. All right, so relative to that angle bisector equation, graphing it, these other problems are pretty basic. Either you're just looking at it, or you're doing some simple arithmetic, or maybe you're having to write a very simple equation and solve it. So there you go. Review the video, and I'll see you in class, and we will. I'll help you however I can. All right, take care.